My name is Puyao. I'm a postdoc at Rice University, and I'm also a fellow at the Center for Operation Research in Cancer. The presentation today is a machine learning approach for adaptive prediction of postoperative length of stay. This is a joint work between Rice University and MD Anderson Cancer Center, involving both operations researchers as well as clinical experts. So let me start with the clinical motivation for this work. First, how do we define the postoperative length of stay, or LOS for short? It is the time from when a patient enters the recovery until they are discharged from the hospital, measured by the number of midnights. So why is it important? So from a clinical perspective, the accurate prediction of length of stay can provide decision support for each patient's care pathway. And from an operational perspective, it directly affects the capacity planning, in particular, the outpatient versus inpatient bed management. So what is the purpose of our work? We want to predict the length of stay in a manner that is both task-based as well as adaptive. So what do I mean by task-based? In our framework, each model answers a specific operational question. For example, at the stage of case request, we want to direct patient to outpatient or inpatient facilities. And after the surgery, we want to use the model to optimize the inpatient bed management. Second, we said our models are adaptive because they're able to incorporate new information, for example, intraoperative data like actual duration of surgery or whether there is an emergency procedure. So let's move on to the application of our work. Currently at MD Anderson, patients with smaller than or equal to 1 midnight length of stay are classified as outpatients and directed to the Mace Clinic. Patients with 2 or more midnights of length of stay are classified as inpatient and directed to the main building. In a recently proposed plan, a new 1PC building is under construction. After its completion, patients with exactly 2 midnights length of stay will be classified as novel outpatient and directed to this new building. So we say our work is powerful because this is a $2.5 million plan, and we can give surgeons confidence that patients can be directed to the right place. So now let's look at the data set we use in this project. So we have more than 140,000 cases from MD Anderson for 8 years. And at the stage of case request, we are able to use the 12 pre-op features as shown in this table. We have the age, the BMI, the sex. For primary service, so we have cases from 23 different departments, including urology, breast, and head and neck. And we also use the primary procedure CPT code. So for residents, we divided patients into 4 groups: local, in-state, USA, and international. For scheduled room duration, we divided all the cases into 5 groups: 0 to 2 hours, 2 to 4, 4 to 6, 6 to 8, and 8+. And for every case, when the procedures are scheduled, it contains definite procedure. It may also contain possible procedure. So we introduce a pre-op feature, the possible procedure to be 1 if there is a possible procedure, and 0 otherwise. Okay, so let me explain the machine learning approach we use. We apply the gradient descent, gradient boost method, namely XGBoost. So this method can be used for both regression and classification tests. In our project, we use it for classification tests. It combines multiple weak learners, namely decision trees, to form a strong predictive model and sequentially minimize errors using gradient descent on a loss function. We split the data set into 3 parts, 64% for training, 16% for validation, and 20% for testing. The key advantage of this method is it has both high accuracy as well as interpretability. Okay, so let's look at the task-based models first. We first consider an ambitious task. We want to subcategorize 0 to 1 midnights versus 2 midnights versus 3 to 6 midnights versus 7 plus midnights. So this is from a high-level hospital management perspective. The matrix of performance we use are sensitivity, specificity, and accuracy. And accuracy is defined to be the number of correct predictions divided by the total number of predictions. So we can see the figure on the right. It shows the ROC curves, one versus the rest. And the accuracy of this project is 0.81. However, if we consider a more modest task, if we only want to subcategorize outpatient versus novel outpatient versus inpatient, so we can see the accuracy increases to 0.87. So what's more, if we consider a binary classification task, if we only want to differentiate conventional outpatient versus inpatient, we can see the accuracy reaches 0.91. So this table shows our 8 tasks in total with their accuracy. So we have introduced 3 of them, and for the remaining, we won't go into the details. Okay, so let's move to the second stage, the postoperative stage. Now we have 7 new features as shown in the orange table. Now we know the actual procedure length, and we can also calculate the difference from the scheduled room duration. And we divided both of these 2 postoperative features into 5 groups. And as we said, for every case, it may contain possible procedure. And now we can introduce 3 postoperative features, whether there is a performed but not scheduled procedure, whether there is a definite procedure but not performed, whether there is a possible procedure that is performed. So we can see after introducing these new features, the table of feature importance has changed. For example, in text 2, the most important feature used to be the scheduled room duration. But now it is replaced by the actual procedure length, as shown in orange. So we can also have see some improvement we get from the adaptive models. So we still use test 2 as the example, where we differentiate 0 to 2 midnight versus 3 plus. On the test set, compared to the pre-OP model, the post-OP model changed 5% of the predictions. On this subset, the pre-OP model has an accuracy only 33%. So we can also see this in the figure on the right. The blue box plots represent the pre-OP model. When it predicts 0 to 2 midnights, the actual average midnights length of stay is 3 midnights. When it predicts 3 plus midnights, the actual average length of stay is 2 midnights. And the post-operative model, as shown in yellow, reversed this situation. It increases the accuracy on this subset from 33% to 67. To conclude, we developed A-task-based models. And for example, in the novel outpatient task, the accuracy is 90%. The adaptive model modified a subset of predictions, improving the accuracy from 33% to 67%. For future work, we noticed that for the primary procedure CPT code, at this time, some of them are wrong entries. So they're actually the first procedure rather than the primary procedure. So we will figure out how to fix this problem. And we noticed that there are, at this time, there are more than 1,400 features, and some of them are very similar, and we will work on grouping similar procedures. And we may also include additional features like the postoperative left values, and we are working on the implementation, and we will apply this method to inform operational planning. Okay, that's all for my presentation. Thank you very much.
Any questions?
Thank you for the great presentation. So thinking about like the situation that MD Anderson was in before the model was developed, where they had to decide between putting patients in May's clinic and putting them in the main building, like how did they make that decision? And then like, were you able to benchmark the accuracy of the traditional method versus the new machine learning method? Or like, how do you consider the human model that was in place before versus the new model that is machine learning driven?
Yeah, thank you for the question. I think at this time, so they're mostly based on the experience of surgeons. There is a software, the Epic, but the inputs are like the service, the CPT code, and it will provide an estimation on the procedure length. So this will be a novel approach to like we can add one more output with the predicted length of stay, and it will provide the surgeon's suggestion that whether this patient can be sent to the main building or the Mace clinic.